Okay, so today we're going to be covering problem solving using annuities. So this is Year 12 General Mathematics Unit 4, Topic 1, Loans, Investments and Annuities, and Subtopic 3, Annuities and Perpetuities. Just going to find my mouse. Okay, so the syllabus descriptor that we are covering today is to solve problems using annuities. For example, determining the amount to be invested in an annuity to provide regular monthly income of a certain amount. And specifically, we're going to be looking at the future values, present values, and use of present and future value tables. Okay, so calculating the future value of an annuity using a formula. So in the previous video, we looked at using the recurrence relation to work out the future value. And that's okay if you're only doing 1 or 2 or 3 compounding periods. But if you have a large number of compounding periods like 100, 200, 300, 400, you don't want to be pressing the calculator button 400 times. And so therefore we can use a formula for large values of n. And so here is our future value formula, where future value A is m, which is the amounts that we're putting in each time, multiplied by 1 plus I to the n take 1, over I, where I is the interest rate period expressed as a decimal, and n is the number of payments. Now, do we have to know this formula off by heart? Well, the QCAA formula sheet actually has the formula here. So if you are starting with a 0 principal balance, you would use this formula. And if you had a starting balance, you would have to add in the compound interest formula, which is also found on the QCAA formula sheet. Calculating the present value of annuity. So the present value is a single sum of money that if you invest in the same terms as the annuity, you'll get the same future value. So there is a formula for that as well. And here it is here where PV stands for present value. M, once again, is the payment amount you're putting in. 1 plus I to the n take 1 over 1 plus, times I, 1 plus I to the n. So if we go back to that formula that we had before for the future value, you can see that the same numerator line is the same, but the denominator, where you just had the interest rate per payment period, now you've actually got 1 plus I to the n as well. So the difference between these two equations is the divisor at the bottom. What if we want to work out the payment amount? Well, we can rearrange the formula sheet so that we have the payment amount is the desired value or the future value multiplied by I over 1 plus I to the n take 1. So if we once again refer to our future value formula that is available on the QCAA form, you'll notice that the A and the M have swapped positions. So where you have A equals M in the future value, in the to work out the payment amount, we swap these around. And the 1 plus I to the n take 1 over 1 has been rearranged upside down as well. So you'll notice that the two formulas here, they've been reciprocated. So a future table. So if we have a large number of values, you can work out a future table. And this we can work out what $1 will earn and then multiply it by however many dollars that we have invested. So here's the future value table. So say, for example, we needed to work out what 4% for 10 years we would look down the 4% column and 10 years, and we would multiply however many dollars we have by 12.0061. We can also do a similar thing working out present value tables. So with the present value table, once again, we look up the percentage rate and the number of years or the number of compounding periods. So say we wanted to work out 6% for compounding periods, we would multiply whatever dollar amount we have by 3.4651. So we're going to get into some examples. So calculating the future value of an annuity. So the question says, using the annuity future value formula, so that tells us we're going to use the formula, calculate the future value of $500 invested every 6 months for 10 years at 6% compounding 6 monthly. Okay, so what information do we know? So $500 is going to be our M value. We're putting it in 6 monthly, so that's 2 compound periods per year. So that means that our 6% compounded 6 monthly, we're going to have to divide this by 2 to work out our percentage rate per compounding period. So let's write down what we know. So we've got to find out A. We know M is 500 because it says here. We've turned our 6% into a decimal. I'm dividing it by 2 to work out the percentage expressed as a decimal per compounding period. Now I have 10 years and 2 compounding periods per year, so that's 20 compounding periods. So write down my equation. So from the QCAA formula sheet, substitute in and get my answer. Now, how do I do that on the calculator? Bring up my trusty calculator, turn it on, clear all the information from there, and let's put in my information. So 500, open brackets, 1.00, whoops, too many O's, 1.03 to the 20th take 1, and I didn't realize that I had, oops, delete, divided by 0.03 equals $13,435.19. So here we have $13,435.19. So in 10 years' time, the future value of the annuity will be $13,435.19. Okay, another example of future of annuity. So in the previous example, our starting balance was 0. So in this example, Jasper has a superannuation account with a balance of $30,000 when he switches jobs. His new employer is going to put $1,200 into this account each month. The account accrues interest at 3.6% per annum compounding monthly. Calculate the balance of his super account after 6 months. Okay, so what information do we know? So it had a starting balance of $30,000. So this part of his money is going to earn compound interest using the compound interest formula. The $1,200 is going to be his M. It's being put in monthly, and the interest rate is 3.6% per annum compounding monthly. So we have to work out it as a decimal per compounding period. So let's write down what we know. So A equals what we've got to find out. M is $1,200. The interest rate is 0.036 divided by 12, or 0.003% expressed as a decimal per compounding period. We want 6 compounding periods, and his principal was $30,000. So in this instance, we have to use the two formulas together. So this part of the formula is the compound interest formula based on the $30,000, and here is our future value based on the annuity. So I substitute in, and I can't do this in my head, so I'm going to get out my trusty calculator, clear my previous information, just move that over slightly so that you can see it, and we're going to do this in two separate parts. So 30, 1, 2, 3 times by 1.003 to the power of 6 equals $30,544.07. So just switch back, and there, right, so that's going to be the value of this. Now I'm going to work out the second part. So 1200, 2 multiplied by 1.003 to the 6. Move my cursor over, take 1 over 0.003. Close my brackets, and I've got $7,254.22. So here's my 30,000. Here's my $7,254.22. Add them together, and I get $37,798.29. So the balance of Jasper's superannuation account after 6 months would be $37,798.29. Okay, let's look at the future value during a withdrawal phase. So Wendy invested her superannuation funds of $375,000 in an annuity that will pay her interest at the rate of 6.12% per annum compounding monthly. Wendy will withdraw a monthly payment of $4,000 from this investment. Use the annuities formula to calculate the balance of Wendy's investment after 10 years. So what do we know? Here's her starting principal of $375,000. Our interest rate is 6.12% per annum compounding monthly, so we need to convert that to a decimal and divide by 12 compounding periods. Our M is her withdrawal amount of $4,000 and 10 years at monthly, so we're going to have 120 compounding periods. So let's write down what we know. We have to find out A, because it says calculate the balance after 10 years. M is $4,000, so that's her withdrawal amount. Our interest rate per compounding period, 6.12% expressed as a decimal, divided by 12 is 0.0051, and our number of compounding periods is 120. Okay, so, and her principal is $375,000. So we write down our formula. So this part of the formula is going to be the interest on the $375,000. This is the annuity of how much money she's going to take out. So substituting into that equation, we get this, and I don't know about you, but I can't do that in my head, so I'm going to bring up my trusty calculator, clear all my previous information, and I'm going to do the first part, 375,000 multiplied by 1.0051 close brackets to the power of 120. Enter. So $690,468.75. Now I'm going to do the second part. So take, just going to do the second part, 4,000. $1.0051 to the power of 120. Move my cursor over. Take 1 over 0.0051. Close brackets. Equals $659,803.92. So go back to the screen. So here we are. Here, 690,000. Take away 659, and I have $30,664.83. So the balance of Wendy's super fund after 10 years of withdrawing $4,000 will be $30,664.83. Okay, so now let's look at an example of the present value of an annuity. So using the formula for present value, determine the present value of a $1,500 per year for 10 years invested at 5% per annum, and explain the context of this problem, what that means. So let's write down the information that we know. We're looking for the present value. Our M is $1,500 a year. My interest rate is 5% per annum expressed as a decimal, and I have 10 compounding periods. So here's the formula for present value. Substitute in, get out my trusty calculator. So get out my trusty calculator, make sure that it's on. 1,500 times 1.05 to the 10th. Move my cursor over, take 1, go down, 0.05 times 1.05 to the 10, close my brackets, press enter, and I get $11,582.60. So here's my present value. So the present value of the annuity is $11,582.60. So what does this mean? It means that if you invest $11,582.60 as a single sum now, it will have the same future value as putting in $1,500 each year for 10 years at 5% interest. So now we're going to work out the payment amount. Calculate the annual contribution needed to obtain $50,000 in 10 years with 4.5% per annum compounded annually. Let's write down what we know. So our A is $50,000. Our M is what we have to work out. Our interest rate is 4.5% expressed as a decimal. And our number of compounding periods is 10. So write down the formula. M equals A, 1 over 1 plus I to the n, take 1. Substitute in, take out my trusty calculator, clear all the previous information, and have 50, whoops, 1, 2, 3, so can we see that? $50,000. Open brackets, 0.045 over 1.045 to the 10th. Oh, delete. Take 1, close brackets, equals $4,068.94. So annual regular payments of $4,068.94 is required to obtain $50,000 in 10 years' time at 4.5% interest compounding annually. Okay, example 6, using future tables. So use the future table to find the value of A where $1,500 is deposited at the end of each year into an account that pays 7% interest compounding annually for 9 years. So here's my table. I want to find 7%, so I'm going to be looking down this column here, 9 years here. So there is my multiplying factor for 7% for 9 years. So I look up the table for $1. I have $1,500, so I multiply my $1,500 by the multiplying factor, pardon me, and I get $17,967 is the future value of my investment. I could use similar tables to work out the present value. So Liam invests $750 per year, 6% per annum for 8 years, compounded annually. Use the present value table to calculate the value of his annuity. So we want 6%, so we're looking down this column, 8 years. So here's our thing. So my number is going to be 6.2098. So I look up the table for 8 years at 6%. My present value is going to be 750 times my multiplying factor. And so my present value will be $4,657.35. So that means that if I invest $4,657.35 now as a single sum, it will have the same future value as if I put $750 in each year for 9 years at 6% interest. So now it's time for you to do some individual practice. So I want you to answer the questions from the textbook on exercise 9.4 on page 315. I want you to answer questions 1 to 10, 15 to 18, and then 21 and 22. Then you're going to complete study on Chapter 9, Concept 3. Remember, make sure you end any previous sessions before you start. So this is like Concept 3. Here's our future value and present value. Remember that when you're doing the study on, you're looking for a little page with the green tick. So have a go at doing these questions from the textbook and then Concept 3. And then when you finish that, come back and check your answers. Okay, so I'm assuming that if you are watching the second part of this video that you have checked your answers and you're either looking to see whether they're right or you are looking to see what you did wrong. So, question 1. Blair invests $450 into a superannuation fund that earns 5.8% interest per annum compounded monthly. His initial balance is $12,000. So that means that we're going to have to use the compound interest formula as well as the future value formula. Calculate the balance of his superannuation after 3 payments. So, what do we know? Well, A is what we're trying to find out. Our M is $450. So our interest rate is 5.8% per annum compounded monthly. So we divide our decimal interest rate by 12. We have 3 compounding periods, and I forgot to write down my starting amount was $12,000. So here's my equation. Substitute into my equation. So this part here is the original $12,000 using the compound interest formula, and this part here is the annuity, putting the $450 in per month. So bring up my trusty calculator, make sure that it's on, clear all the information beforehand. So 12,000 times 1.004833 to the power of 3 equals $12,174.83. Now I'm going to do the second part. 450 times 1.004833 to the power of 3. Move my cursor over. Take 1. Underneath 0.004833. Enter is $1,356.54. So when I add those together, I get $13,531.38. So that would be answer D. Okay, question 2. Complete the table following the payment made, interest earned, and the account balance for the following information. So the initial balance is $30,000. My interest rate is 5% per annum, compounding monthly, and I'm adding $800 into my account. So here I convert my interest rate into a decimal per compounding period. I multiply that by my starting balance to work out my interest. So here $125. Here I'm adding 125 plus the 800 to my starting balance, and that becomes the new amount that I'm going to multiply by. So this is my completed table here. Question 3. Using the annuities recurrence relation for the following information, where A3 is 28,000. Our interest rate is 7.5% per annum compounding monthly. My payment amount is $1,100. My question says calculate the value of A2. So the question tells me to use the recurrence relation. So that's a bit of a hint. So first let's write down the recurrence relation for this. So I work out what my R is. Right. So I'm working out this bit here is 1.089583. So my AN plus 1 equals 1.089583 times A to the N plus my 1100. So there's my recurrence relation equation. So I know that A3 equals my rate times A2 plus 1100. So I'm going to substitute in my $28,000. Right. So my next step is to move this 1100 to this side of the equation. So I subtract it from both sides. So 28,000 take away $1,100 gives me 26,900 equals my R value times A2. So now I need to divide both sides by 1.089583 and I get my A2 value $26,732.92, which I can see here is answer A. Okay, question 4. Using the annuities investment recurrence with the initial balance of $220,000, my interest rate is 5.2% per annum compounded weekly, and my payment amount is $450 per week. It says calculate the value of A3. Okay, so it tells us to use the annuities formula. So I'm going to start by using the annuities formula. So 1 plus 0.52 over 52 is 1.001. My A to the 0, my starting value is 220,000. I'm putting in 450. So here's my recurrence relation. So A1, A2, A3. Now I could also do this using the future value equation. So put down the same information that I had before. Now this is the interest earned on the 220,000. This is the future value of the annuity. Plug them in together, just as I have in previous examples. Add them together, and you can see I get the same answer. So my answer is letter C. Okay, question 5, the last question. So a comparison of two superannuation accounts, both with a starting balance of $100,000. So plan A has 6.8% compounding monthly with $800 paid per month. Plan B has 5% compounding monthly with $950 put in per month. It says, how many months is the balance of each account the same, not including the initial balance? Okay, so let's make a little here. Plan A, here's our recurrence relation equation. So I've worked out the first month is 100,000. My second month is $101,366.67. My second month, 102,000, 104,000. And I've done the same thing for Plan B. So here's my recurrence relation. So the question says, how many months is the balance of the account the same, not including the initial balance? Okay, so these ones are the same. The first month, these aren't. Neither of these. So only 1 month of these are they the same. So our answer is B.